Hi viewers, this is Chandamala Chandrasekhar. Welcome to the video solution of Cambridge IGCSE Physics Paper 6 Alternative to Practical 2022 February March. This is my first attempt to make a video solution. So without wasting time, let's move on to the first question. So first question, student investigates the extension of a spring and uses it to determine the weight of a meters rule. The spring is shown full size in figure 1.1 and figure 1.2. Figure 1.1 shows the spring without any load. Figure 1.2 shows the spring with a load of 1 Newton suspended from it. So clearly observe the diagram. When it is without load, the length of the spring is represented as L0, and when it is extended with load, the length is represented as Ls. So A part, on figure 1.1, measure the length L0 of the spring without any load. So as we have identified what is L0, if you use your ruler and measure, it is 1.9 centimeter. Second part, on figure 1.2, measure the stretched length Ls of the spring. So from the stretched with the load, the Ls will be 5.9 centimeters. Coming to the B part, the student attaches a meter rule to the spring with a wire hook as shown in figure 1.3. The scale of the meter rule faces upwards. She ensures that the meter rule is horizontal. So have a clear observation on the meter rule, a load, and the spring position and the bench. So based on this diagram, the next question is, briefly describe how to check that the rule is horizontal. You may draw a diagram if it helps to explain your answer. So we can draw a diagram, or if it is without diagram also you can explain your answer. Measure the height of the ruler at two end positions from the bench, or use water level or spirit level. So with these techniques we can check whether the ruler is exactly horizontal from the bench or not. So C part question. The student moves the load W to a distance D is equal to 20 centimeter, 30 centimeter, 40 centimeter, 50 centimeter and 60 centimeter from the pivot. She reads the length L of the spring for each value of D. Her readings are shown in table 1.1. Using the values from table 1.1, plot a graph of extension against D, start the axis at the origin. So in this type of graphs, have a careful observation on the table and the readings given. So here the D readings are 20.0, 30.0. So after the point, they all are represented to one decimal. Extension also represented up to one decimal after the point. So when we are plotting, first we need to label the axis, x-axis and y-axis. And on x-axis what they are asked to represent D and its unit is centimeter. And on y-axis we need to represent the extension, that unit is centimeter. So just for labeling x and y-axis and assigning the quantity with unit, you will be getting 2 marks. And for choosing the appropriate scale, 10, 20, though it is 10, 20, 30, but we need to represent according to the table, that is 10.0, 20.0, 30.0, 40.0, 50.0, 60.0. Similarly, the maximum value is up to 9 in our table. So we need to take from 2 to 10, but after the point there is one decimal. So all our readings should be 2.0, 4.0, 6.0, 8.0 and 10.0. So as per the table, if you plot the points, you will be getting all these 5 points, and draw a best line of it and draw it. So whenever you are plotting a graphical line like this, make sure the line is as thin as possible. So next question, from your graph determine L, the value of L when D is equal to 0 centimeter. So when this D is 0 centimeter, so what will be the extension here? This is the extension. So in order to obtain this value, we need to extrapolate the graph line backwards, and we need to represent like this with the dotted lines. So where it is intersecting the y-axis, that point we need to take. So it is approximately 4.6 centimeter. So the third part, calculate WR, the weight of the meter rule, using your value of L from C2, the values of L0 and LS from A and the equation. So clearly we are given an equation. K is equal to 1 Newton also is mentioned in the question. So as it is, we need to substitute all the values that we have calculated in the previous questions. So when you substitute L value, L0 is 1.9 and LS is 5.9 into K is given as 1 Newton. So 1 Newton, if you substitute, your resultant weight will be 1.35 Newtons. So since it is a weight, you have to write the correct unit as Newton. Then coming to the D part, first one, it is sometimes difficult to position the load W on the scale of the meter rule at the correct distance D from the pivot. Suggest one change to the apparatus to overcome this difficulty. Actually, from the tabular readings, distance is mentioned in centimeters. From the pivot, we need to find the distance. So the distance should be exactly perpendicular. So what we need to do is draw a vertical line from the pivot. From the pivot, we need to draw exactly a perpendicular line. And from the center of the load also, we need to identify one vertical line. Then we can exactly find the distance. So draw a vertical line from the center of the load and center of the pivot. So that will help us to identify the correct position of load. Then moving on to D, second part, suggest one possible source of inaccuracy other than the difficulty described in D1. Assume that the experiment is carried out carefully. So as it is mentioned, the experiment is carried out carefully. We cannot simply write it is because of parallax error. So something other than that we need to mention. So since it is having a spring, the coils may have uneven spaces. So your answer can be the coils of spring is not evenly spaced, or the extension is not proportional to the load from Hooke's law. we can write that point. I hope this question is clear for you. Let's move on to the next question. Second question. A student investigates the thermal insulation properties of air. He places a thermometer in a clamp as shown in figure 2.1. So observe the diagram figure carefully. So thermometer reading is given in a zoomed picture. So from that first part A, record room temperature theta R shown on the thermometer in figure 2.1. So simply from this mercury thread we need to read the temperature. So it is between 20 and 30 there are 10 readings. So after 20, 1, 2 and 3, so it is 23 degrees Celsius. Then B part, the student uses the apparatus shown in figure 2.1, figure 2.2 and figure 2.3 to investigate the thermal properties of air. Beakers A and B are made of glass. Beaker A is placed inside beaker B for the second part of the experiment as shown in figure 2.3. The lid fits tightly in beaker B. First part, the student removes the lid from beaker A. He pours 150 centimeter cube of hot water into beaker A and replaces the lid. He inserts the thermometer into the hot water and records the temperature theta at time t is equal to 0 and then every 30 seconds. Describe two precautions that can be taken to ensure that the temperature reading is as accurate as possible. So in this question, it is clear that we are investigating cooling properties. He pours hot water into the beakers, first case, and at every 30 seconds, what is the temperature fall we have to note down. In beaker A and beaker A placed in beaker B of somewhat bigger size and there is some air gap. So here in figure 2.3 there is a clear air gap and in figure 2.2 beaker A there is no air gap, it is placed alone. So describe two precautions means when we are starting the experiment with beaker A alone, the initial temperature in this case and the initial temperature in second case should be same. That means the same hot water, same quantity of water we need to take. So the initial temperature of hot water in two cases need to be the same. Then the exact cooling rate can be investigated. And one more precaution what we can write is wait for some time until the mercury thread settles and then record the temperature. So after every 30 seconds we need to find the temperature and exactly wait for some time and record the mercury thread clearly. That will give you the correct readings. So these two precautions we can write. Moving to the next question. The student pours away the water from beaker A. He then replaces beaker A inside beaker B so that there is an air gap between the two beakers as shown in figure 2.3. He repeats the process described in B1. His readings are shown in table 2.1. Add units to the column headings in table 2.1. So this is a common type of question asked in IGCSE ATP paper. So clearly we need to observe whether these headings are provided with symbol and unit. So first one we know it is clearly time, so time units are seconds and temperature for beaker A, beaker B. So temperature is measured in degrees Celsius. So moving on to the next question. Write a conclusion stating whether the air gap affects the rate of cooling of water. Justify your answer by reference to values from table 2.1. So clearly, if you look at the table, the temperature fall is less in second case than in first case, beaker A alone. So we need to write a conclusion is yes, the air gap affects the rate of cooling as the temperature difference in both cases is not same. So we need to represent what is the temperature difference and in which case the temperature difference is less. So temperature difference in second case is only 6.5. That means here the temperature is decreased very slowly. Cooling rate is very less, but here the cooling rate is very fast. Then D part. A student suggests that glass is a thermal insulator and the experiment does not just test the effect of air gap. Suggest one change to the apparatus that would test the air gap more effectively. So instead of taking glass, we can write any other material which is a good conductor and write our answer. So repeat the same experiment with beaker A and beaker A in beaker B, first case and second case, made of same metals. So E part, another student repeats this experiment using the same apparatus shown in figure 2.1, figure 2.2 and figure 2.3. State two variables that she should control in order to obtain readings as close as possible to the readings in table 2.1. So two variables that we should control is, we have to keep constant, is first one, the initial temperature in beaker A and beaker A placed in B need to be the same. And second point what we can write is the volume of water in each case should be same. Then our readings will be as close as possible to the readings mentioned in table 2.1. So our next question, F part, calculate the average cooling rate R for beaker A cooling on its own. Use the readings for beaker A in table 2.1 and the equation. R is equal to, an equation is given. So where T is 180 seconds and theta naught is the initial temperature and theta 180 is the temperature at 180 seconds. Include the unit for the cooling rate. So just substitute the values of theta naught from the table and theta 180. These are for beaker A only, not the second case. So keep that in mind and write the values. T is 180 seconds, then you are getting R is equal to 0.09. Since it is temperature divided by time, degree Celsius divided by seconds is the unit. So that's all for second question. I hope you understood up to second question. Then let's move on to the third question. So third question is from the unit light. It is about a ray diagram. A student investigates the refraction of light by a transparent block. The student's ray trace sheet is shown full size in figure 3.1. First part A, the student places a transparent block ABCD near the center of the ray trace sheet as indicated in figure 3.1. So in the first part, draw a normal to point N extending above AB. Label the upper end of the normal with the letter L. So if you look at, so upper end of the normal only should be labeled as L. Okay, after drawing the normal upwards, the upper end should be labeled as L. Then second part, the student draws the line EN as shown in figure 3.1. On figure 3.1, measure the angle theta 1 between the line LN and EN. So clearly it is the angle between the incident ray and the normal. So if you use your protractor and without any parallax error, if you measure carefully, you will get theta 1 is equal to 15 degrees. So for B part, the student places two pins P1 and P2 on the line EN as shown in figure 3.1. Measure the distance D between the pins P1 and P2. So EN is an incident line. On the incident line there are two pins placed. So we are asked to find the distance between these two pins. So since it is a scaled diagram, just place your ruler and find the distance between P1 and P2. It is 2.9 centimeters. Then next question, suggest whether the two pins are a suitable distance apart for accurate ray tracing. Explain your answer. So already we have learned the distance between two pins should be at least 5 centimeter. So since 2.9 is not reaching our value, so a statement we can write is to no. We can write no, and the explanation is the minimum distance between pins should be at least 5 centimeter. Then the C part, the student places a plane mirror on line CD and views the images of pins P1 and P2 through the transparent block. She places two pins P3 and P4 so that these pins and the images of pins P1 and P2 all appear exactly one behind the other. On figure 3.1, draw a line through points P3 and P4 and extend the line 3 centimeters below CD. So this first part, exactly you have to draw a line joining of P3 and P4 points. Exactly, the line should touch P3 and P4, and the extended line also exactly 3 centimeters only. Below CD, it should be 3 centimeters. Label the point at which the line meets AB with the letter G. So where this line intersecting AB, you have to name it as G. Then third part, label the lower end of the line with the letter H. See, lower end means the extreme end point of that line which is joining P3 and P4. That lower end only you should label as H. So for these three correct drawing, you will be getting 1 mark. Then B part, the student repeats the procedure for an angle theta 2, 35 degrees. She places two pins P5 and P6 so that these pins and the images of pins P1 and P2 all appear exactly one behind the other. Same procedure but with a different angle, that is 35 degrees. On figure 3.1, draw a line through points P5, P6 and extend the line 3 cm below CD. Label the point at which this line meets AB with the letter R. So we need to join once again a line joining P4 point and P6, and that should extend below CD up to only 3 centimeters. And where it is touching AB, you have to label it as R, that intersecting point, and the lower end only you have to label as S. Then fourth part, label the point at which GH and RS cross with each other with the letter T. So the two lines which you have drawn, P3 and P4, P5 and P6, these two lines below CD, they are intersecting at a point. That intersecting point should be labeled as T. Then next question, measure the angle beta, where beta is the angle between lines GT and RT. So from the lower side, if you measure the angle between these two lines, that is beta, it is 18 degrees. So moving on to the next question, a student suggests that the angle beta should be equal to theta s, where theta s is calculated using the equation clearly shown, this equation here. So you know theta 2 is 35 degrees and theta 1 is, we have mentioned in a previous question, that is 15 degrees. So if you subtract, you are getting 20 degrees. But what is this 20 degrees is equal to theta s and beta is 18 degrees. So beta value from the previous question, it is only 18 degrees, but theta s is 20 degrees. So the student suggestion is wrong. So we can state whether your results from A2 and D support this suggestion. So what is our statement is, the statement is no, it is not supporting. So justify your answer by reference to values from your results. So from our results, the results of theta s and beta are not same, because theta s is 20 degrees and beta is 18 degrees. Then the next part is E question. Suggest two precautions to take in this type of experiment to ensure accurate results. So since this experiment is with pins and ray diagram, so ensure that always the pins are in vertical or perpendicular to the plane of the paper. And when we are viewing these pins, always view the pins from the base. If you want write a different precaution, the other one also you can write, use thin pencil lines. When you are drawing the lines, you have to use thin pencil lines. Moving on to the F part, suggest one reason why different students, all carrying out this experiment carefully, may not obtain identical results. So the problem in different students may be drawing the pencil lines. Students might have used thick pencil lines while drawing. Some might have used thin lines and some might have used thick lines. Then the angle measurement is inaccurate. And another one, if you like, you can write, actually they asked only one and it's for 1 mark. You can also remember the normal line is not correctly drawn. If the normal line is not correctly drawn, also we will get the angles are wrong. So that's all for the third question. I hope you understood up to these three questions. Let's move on to the next question, last question. So usually the last question is like one experiment description. We need to clearly know what are the dependent variables, independent variables, and the precautions, and the diagram, schematic circuit, or the diagram for that particular experiment. A student investigates the heating of water using an immersion water heater. An immersion heater is an electrical heater that can be placed directly into water. Plan an experiment to investigate how one factor affects the rate at which the temperature of the water rises when heated using an immersion heater. The apparatus available includes an immersion heater, equipment to connect the circuit, part of which is shown in figure 4.1, a stop clock, a beaker to contain the water. In your plan, you should, here starts the question. First one is, state the one factor which you have chosen and list any additional apparatus needed to measure the factor. Complete the circuit diagram in figure 4.1. That means some incomplete diagram is mentioned, so that we have to complete. Explain how to do the experiment, including any precautions to ensure reliable results. So explain how to do the experiment is a common type of question in the fourth question in many past paper questions. So for this part, you need to keep the heading as a method of the experiment. So for every bullet that is mentioned in the question paper, we have to clearly keep the heading and write the answer. Circuit diagram, you have to write a circuit and draw that. Actually, it is given in the question paper, so we will complete there. And the third bullet point is explain, means we need to keep the heading as method and we need to write all the explanation. And fourth bullet, state the key variables to be kept constant. So here we can include our heading as controlled variables. Then fifth one, draw a table. So here we can keep heading as tabular form or table, and you can just draw the table with the column headings to show how to display the readings. You are not required to enter any readings in the table. Last part is explain how to use the readings to reach a conclusion. This is also a very similar type of question in all past paper questions in fourth question. So for all these 6 bullets mentioned in the question paper, I have clearly explained the answer with this headings. So let's check the answer. This is the circuit diagram. First we need to complete the circuit diagram. So it is also asked suggest or include any additional apparatus. So thermometer should be included here, stopwatch should be included. Then the remaining bullets answers are like this. First one is factor we choose. What factor we have chose to carry out the experiment is of quantity of water. So we will be varying the quantity of water like 500 milliliters, and we will be checking the readings, and then we will be repeating with 1000 milliliters, next to 1500 milliliters, 2000 milliliters, so on. Then additional apparatus that is not mentioned in the question is thermometer. So we need a thermometer in order to check the heating rate. Then the method, so they ask to explain the procedure. So place the thermometer and pour water in a beaker and switch on the power supply. After a fixed time period, so for every quantity of water we have to fix a time period. Wait for thermometer reading and note down the temperature. Repeat the same method with the other quantities of water. So this will give you the complete method. And precautions, see that the same time interval is maintained for all quantities of water. And another precaution can be the bulb of the thermometer is not touching the walls of the beaker. Then the next one is controlled variables. What are the controlled variables is it is constant throughout our experiment. That is, first one, time duration. Second one is amount of energy supplied should be same. Only what we are varying is amount of quantity of water. Then the table representing our experiment is amount of water in centimeter cube, that is volume, and the time is fixed and it should be represented and its unit is second, and finally we record the temperature and temperature unit is degree Celsius. So depending on these column headings and experiment, we can conclude, that is conclusion heading, The rate of heating of water is inversely proportional to the amount of water. That is, the lower the water, faster the water gets heated. So it is inversely proportional. Or you can write the below answer as well. More the quantity of water, lower is the rate of heating the water. So that's all for the video solution of IGCSE Physics Paper 62 2022. Thank you for watching this video. If you feel it is useful, please like and share. That's all. Bye bye.